Hello. Okay. Hello, everyone. Wait, what? Okay. That's probably why it didn't work. Alright. We're finally in. So, we're kind of working on something that sort of really hasn't been done before. I don't know if it's been done before. I mean, there's a Prop C version. I know that exists, but none like what is it? None like the Java edition. So okay, so one thing about the Bedrock replay that I'm working on is going to be the separate application. Now, if you've seen my community posts, I did do a poll on this, and the majority of you selected separate application. So we're technically building a Minecraft clone, but the difference is basically it'll be used as a replay engine. Oh yeah, and the own software I could port it over to. Oh yeah, I'll turn that music down. Right. So hold on. I'm gonna turn it up a bit later, but yeah. So that's so I could technically port it over to mobile and console. I'm still trying to get into the actual 3D engine stuff. I'm just trying to get that done first before we start actually moving on to getting a proxy set up and then a replay set up. So yeah, it's a big task, but it's something that I'm sort of working on. Alright, so I'll actually show you what I've got. So currently, this is as far as I've got currently. I have been following a tutorial series. This is as far as I've got. It's its own engine at the moment. I still have to implement the chunking, which I'm going to do today. Even though I'm a bit half brain dead. But yeah, this is as far as I've got. So we're going to start working on the chunking side. And yeah, as you can see, I've actually got GLSL coding, vertice coding, then I have to set up my own render pipeline, all of this stuff. Then we've got the texture here. Oh my gosh, okay. That's either odd. Alright, then we've got these blocks, which I'm going to set up today. Then the block data, which is kind of set up. And you can see here that I'm actually defining each vertice. So there's a lot going on here at the moment, even though I have barely started. So yeah. At least I've got a camera set up. You know, this was kind of a bit hard to set up, but I'm following a tutorial, so it wasn't too hard. So actually, we'll get started. So I'm gonna pause the music. So I'm actually following this tutorial here. I'm up to the chunking part. So this guy coding with Sphere, he actually did this tutorial. So I'm just gonna, since I'm still learning a lot of this stuff, well, I'm very new to all this stuff, I've just been following this. But then after that, I'm actually gonna modify this to deal with the Bedrock replay, and then hopefully I should know a bit more once I finish this. So we're gonna get started. So we're up to this part.
We're going to create our data from this. So here we're going to go back here and we're going to make sure we spell it right. We have the face data, which contains our vertices and our texture coordinates. And I'm going to create a new list here. And I'm going to do a list, a private list of, and then, or actually it's a dictionary, my apologies. A dictionary where the key is going to be the faces. And then the value is going to be the face data. And this is going to be our faces. So here we're going to do faces equals a new dictionary. And then here we're going to actually define everything inside of our dictionary. So first thing we're going to do is we're going to do faces.front. And then what we're going to do is...
Wait, how do you do that? Oh, okay. Face data. Faces. So we're just going to set up the same thing. Vector 3 position. And of course we're doing position is equal to position, then faces is equal to.
Is we are simply going to do for our value, we are going to do add transformed vertices, and then we're going to need to send it an argument. And I don't know why it autofills that, but for this, we're going to take in a list of vector 3 vertices for here, just so we don't.
Oh, whoops, I did that wrong. This is an object, so. Oh, wait, hold up. Oops, that's wrong. Here we go, that works. Then, of course.
Get in our issue here, and we're going to also return a list of vector 3 here.
Oh, interesting. So we do the front, and then we say add transformed vertices, which is that. And of course, I have got this wrong because I'm not declaring a dictionary. New dictionary faces face data. And of course, we have to do that. Then we did that wrong. Okay, so like that. And like that. And then this is a okay. So list vector 3 and vertices. Wait, no, hold up. What's he doing here? Oh, wait, no, that's wrong. List vector 3 vertices, then we're doing the other stuff. Doesn't really matter right now. Okay, there we go.
Here for our add transform vertices. And so for this add transform vertices, we're going to send the face data raw dot raw vertex data, and then it's going to be at, and this is going to be at faces dot front. And we're getting a bit of an error here. Oh, I made a mistake. So we're actually using the face data. We're not just getting a list of vector 3. So here I'm going to cut this, but save it. And then for the value, I'm going to do a new face data. And this face data is going to have the vertices equal to this. And then the UV, we're going to handle in a bit. First, let's go ahead and get this data working fully. So for this, let's go ahead and first add this.
Oh, your returns. List vector 3, add transform data, and then
Extra parentheses here. And what we're going to do is we're going to create this add transforms vertices. So what we're going to do is we're going to make a new list of vector 3 inside this method here. And this is going to be our transform vertices. And then we're going to do for each vertex and vertices. This is being very helpful. We're going to do transform vertices dot add, and then we're going to do vert plus, and this is going to have the position. So for this, we already have our position defined up here publicly. So I'm just going to do position here since we're not going to be changing that. And then all we want to do is return the transform vertices at the end. And that is transforming our vertices properly.
Use the okay, no, he uses the actual block position. So it's like that. And trying that. Okay.
And for the UV data, we can define the basic UV data here. We can define a default one here if we want to. And I could definitely do that. So I'm gonna do just a simple
Alright, just one note. I am gonna change all of this. So this will so what I'm actually thinking here is the block data is defining here. This can all be the default cube model. And then everything else is going to be data driven. So everything in the JSON files and all of those things, that's going to be data driven. So I'm going to have to load that in a pack manager or something. and then I'm gonna have to convert that into data like this. So it's a big thing. So I can support add-ons. Oh my gosh, Demon, can you do that if you can? Oh my gosh.
Vertex data here somewhere. Actually, since it's temporary, I'm just going to put it at the top here. And I'm just going to say a list of vector 2 uv equals a new list of vector 2, and here, oh my gosh, why is it doing that? Here, you know, C# Visual Studio sometimes annoys me. Here, since the vertex data is the same for all 6 faces, we only need to add it once. This is going to change.
Oh, interesting, interesting, interesting. Okay, okay, I did not know that. Um, hold up, hold up. So if we've got them all around the same,
And I could text data here somewhere. Actually, since it's temporary, I'm just going to put it at the top here. And I'm just going to see, oh my god, it annoys me. I only need to add it once.
so he's got the texture coordinates under what file? It looks like he's in the renderer file, so I am gonna do that. And then we can just copy that over and paste it over.
Since the vertex data is the same for all 6 faces, we only need to add it once. This is going to change when we have multiple blocks with different faces, of course. But this is going to be our simple default UV. And so this will just simplify it a bit. So now for our UV, we're just going to do UV equals this dot UV. Actually, I'm going to call it dirt UV, just so we don't have any confusion. This UV equals dirt UV, and that's our faces.front. So now we can add all.
Instead of just UV, I'm gonna say like texture. Text UV. That should work. Should it? Then we can apply this to all block types, I believe. And then we can just say is that not working? UV is equal to text UV. And of course, this is an array, so that won't work.
All of these using this system. So let's just copy this over, add our comma. Oh, we don't actually, the parentheses is supposed to be here, and the parentheses is supposed to be here, and then we don't need this parentheses here. Whoopsies. Okay, now we can copy it over properly. It's a little bit of a mess, like organizationally, but there we go. We have our 6 faces, and now all we have to do is we do back, left, right, top, bottom, and then here we do the same thing. So back, left, right, top, bottom. And so now all we're doing is we are storing this in dictionaries where we can use this get face and then return it.
So we're doing that's front, that's back, left, right, top. Right, hopefully that will work.
So all we're going to do here is this is just going to return a of type face data, and we are going to return faces at face. And see how simple that is? So we're just creating this dictionary where the keys are of this enum type, and we're returning a face.
Oh wait, and he does that. Faces, face. Right, that should do it.
And see how simple that is? So we're just creating this dictionary where the keys are of this enum type, and we're returning our vertices and our UVs, which makes it very, very simple to get the data here. So this is actually relatively organized, especially compared to my original example, so I'm pretty impressed with that. Let's go ahead and create a chunk class now that's going to be using this data. So here I'm going to create a new item, and this item is going to be a chunk.cs. And here we're going to create a couple of things. So the first thing we're going to do is we're going to do a private list of vector 3. And this is going to be our our chunk vertices. And then here we're going to do a private list of vector 2, and this is going to be our chunk UVs. And then we're going to do a private list of unsigned integers, chunk indices. And then we're going to have a constructor, so public chunk. This is going to take in the position, and I believe that's it. So now we need to define some constants here. So I'm going to do a constant int size equals.
Alright, I don't know if many of you are following on along. So, actually, uh, doing here is, well, technically what we're doing here is, well, since, because GPUs actually draw in triangles, and not in actual vertices, well, they sort of do draw in vertices, but mainly they draw in triangles only. So what we're defining here is like we're defining the vertices of each triangle. So essentially you've got two triangles per square face. And then what you've got is the UV, which is the texture that is applied to that face. And then you've got the indices, which actually tell the GPU how to draw between these vertices, if that makes a lot of sense. So, yeah. I mean, like, I'm not even sure half of the stuff that he's doing here, so, um, yeah.
16, and I'm only going to use size. I'm not going to use width and depth because chunk is an even 16 by 16. We are going to be working with height in the future, but we're not going to do that right now. I don't think so, or we might actually. So I'm going to just write one constant int chunk height, or I'll do height here, equals, and let's just do 32, I guess. So now we're going to do one more thing. We're going to do our public vec3 position. And this is just going to be given to us in the constructor. We got to make sure we spell it right too. Position equals position. That's pretty cool. Now we need a couple methods to actually take this data. So the first thing we need to do is we're going to do a public void gen world. And this is going to generate the actual data, but we're not going to use that right now because it's too much to do in one tutorial. Then we're going to do a public void gen blocks. This is going to take the data. Actually, I'm going to call this gen chunk because that's more accurate. It's not genning the entire world. And this is going to generate the appropriate block faces given the data. And this is going to generate the data. And then here we're going to do a public void build chunk, and this is going to take data and process it for rendering. And then we're going to do a public void render. This is going to take in a shader program. I'm going to call it program. And this is going to be just drawing the chunk. So drawing the chunk. So we're not going to mess with this. We're going to make some fake little dummy data to make a tiny little 2-block world and see how far we can go with that. So here,
What's he do here? Draw the chunk. Doesn't really matter. We name it. Oh yeah, the reason why I use actually summary is because they actually come up with in the actual thing. So if we did something like hold on, let me get an example up here. So if we did something like if I can get my mouse on here, new chunk, and then we just said that, then basically you can see here, if we click on one of these, our description pops up on the actual IntelliSense. So it's a nice thing to have. So we'll just have that. Okay, no idea. Generate data. I believe this won't actually, I'm not entirely sure if I'm going to actually use this. I might delete it later when I modify this. for now, this is all just a learning process. So yeah.
What we're going to do is we're simply going to be looping through. I'm going to do a simple for loop here. So I'm going to do for int I equals 0, I is less than, I'm going to do 3 blocks, I plus plus. And here we're going to do a simple thing. We're just going to add a new block to all of these. And so for this, we're going to simply we're going to add data to all of these. So we're going to go ahead and I guess we'll add the front faces for now. So I'm going to do a block equals a new block. This is going to take any position. So we're going to do a new vec3, and this vec3, we're going to be changing the x. So we're going to do I 0 0, and here we're going to do chunk verts add range, or we're going to do var front face data equals block dot get face, and this is going to take in faces dot front. So now this stores our face data. So now we can.
That's wrong. That naming convention is wrong. Hello, Peanut. Alright, that should do it.
We can do chunk verts dot add range, which is going to add everything within a list, and this is going to simply take in the front face data dot vertices, and then we can do chunk chunk UVs dot.
Naming conventions are incorrect. What's going on? I'm gonna make these because why not? Oh, actually. Right, that should rename everything so easy. And hopefully there are no errors. What happens if I build this? Are there any errors? There's a couple of warnings, but no errors. Okay, so we're good.
Add range front face data dot UV. And now we need to add the indices, because remember we need to index.
Yeah, what did you do? Oh wait, we went into the chunk. And then we do chunk UV stuff. Front face data.uv.
What we're drawing. And so for this, I have a little thing that I like to do. And this, I don't know if this is honestly the best way, but this is what has worked for me. So I'm going to be completely like transparent with you and just say, this is what I came up with. This is not ingenious. So I'm going to do a private int index count. And then what we're going to do here is we're simply just going to do public void add indices for face, and this is just going to do we're literally just going to add the amount of indices. So, or we're just going to add indices between a range int amount faces. And here I'm actually going to reference the original one that I wrote. So here what we're going to do, I'm going to go ahead and just show it first. If we go below all of my chunk generation, all I'm doing is I am incrementing the index count every time I add a face, and then I'm adding these with that new index count, because the index count needs to go from 0 to the amount of vertices that we have. And since we use 4 vertices per face, we're going to increment it by 4 every time we add a face. So knowing that, we can do for int I equals 0, I is less than amount faces I plus plus, and then we can do chunk indices dot add, and here we're just going to do we're going to do 0 plus the index count, and here whoops, from int to uint, int from to, did I typecast it? I think I might have typecasted it. Did I? Index count, I made it an unsigned integer. Okay, that makes sense because it's never going to be negative anyway. So uint index count, Okay, and now we just want to copy and paste this to make 6 of them, since we have 6 indices per per face. And now we just need to look at our indices at the pattern. Remember, the pattern is 0, 1, 2, 2, 3, 0. So we're just going to take that pattern, go to our chunk here, and we're going to do 0, 1, 2, 2, 3, 0. And then we're just going to increment our index count by 4. Okay, so that is our entire add indices. So now we just need to do chunk. Actually, we don't even need to do that. We just need to simply do add indices, and then we need an amount. So for this, we're just going to add 1, since we only have one face, and that will be our entire block. And now we have all this data inside of our different things here. So now we need to simply build this. And the way we're going to build it is just how we do normally. So we're going to create a new VAO, and we're going to use it for all this stuff. So here, I'm going to create a VAO, chunk VAO.
Oh gosh. Oh yeah, that's right. Create a draw call for every chunk. That makes sense. Okay. So VAO. VAO.
And then I'm going to create a VBO, chunk VBO, or chunk vertex VBO, and then a VBO chunk UV VBO, and then I'm going to create an IBO chunk IBO. I believe that's all we need for now. So now all we need to do is just use this in our
Oh my gosh.
build chunk here. So I'm going to do chunk VAO equals a new VAO. I'm going to do chunk VAO dot bind, and then we can do chunk vertex VBO equals a new VBO. This is going to take in our data, and for this we're going to do our chunk vertices. And then what we're going to do is we're going to do chunk
What? What do you? What? What? Okay. Um. Right. So we have the VAO. So we build VAO and bind it. So this is binding it to the GPU, and then we're gonna say VBO. It's a new VBO, and then we take in the chunk UVs, I believe it was.
I believe that's all we need for now. So now all we need to do
Whatever,
is
so.
just use this in our build chunk here. So I'm going to
Oh
do
wait, no,
chunk
no, no, no.
VAO equals a new
Here's
VAO.
chunk
I'm
vertex.
going to do chunk VAO dot bind, and then we can do chunk vertex VBO equals a new VBO. This is going to take in our data, and for this we're going to do our chunk vertices. And then what we're going to do is we're going to do chunk VAO, or chunk vertex VBO dot bind, and then we're going to do chunk VAO dot link to VAO, and then we need to send the location and size, so 0, 3, and then the actual data, which is the chunk vertex VBO, or not the data, but the VBO object. And then we're going to do the exact same thing for the texture coordinates, so the chunk UV VBO.
Build VBO UV slash texture. Bind it. That makes no sense. Oh, it doesn't really matter at this point. I'm still learning.
Equals a new VBO. This is going to take in our chunk UVs, and then the chunk UV VBO dot bind, and then the chunk VAO dot link to VAO. Send it 1, and then
Those are chunk UVs. That's what I want. Text VBO dot bind. That's incorrect. Naming. Then we do text VBO dot link. Nope. We want the VAO dot link to VAO. And then we want this on location of 1. The size is 2 because we're using vector 2. And then we just link the text to text.
2 because we only have an x and a y for texture coordinates, and then the chunk UVBO. Now we need to create an indices, so we're going to do our chunk IBO equals a new IBO. This is going to take in our data, which is going to be our chunk indices. And that's all we need, I believe. So now in the render, we can simply do program.bind, and then we can do chunk VAO.bind, and then we can do, oh, we need to actually have the textures. My apologies. So for the texture, we are simply going to bind the texture that we need. And since we're using an atlas, we only need one texture, which makes it very, very simple. So texture, and then here we're going to create our texture. So texture equals a new texture, and this is going to
Z what? Oh, okay. Is he doing that? No, okay. Nope. Okay. That's a bit of an issue. Image texture. We'll just say img texture. Img texture is equal to new texture.
take in the file path. I'm going to make sure I have the file path right, so it should be just this. However, we might have to move back one because we're inside of this folder. I'm going to test that out, make sure. But yeah, let's just make sure that we'll just add this new texture here, and then we'll do simply texture.bind. Now that we've bound everything, we can do GL. Whoa, GL. I need to import OpenGL or OpenTK here. So
And could
using
use autocomplete.
OpenTK.graphics.OpenGL4. Now we can do GL.draw elements. This is going to take primitive type dot triangles, and then we need the count, which is going to be our index count actually, and then we're going to need the type, which is going to be draw elements type dot unsigned integer, and then we need just the 0 for, so we start at the beginning. And this is going to say cannot convert from uint to int. So we might need to do is we need to do chunk.
Can you just cast it?
Indices dot count. Okay, now
Oh wait.
if all that works, we should be good.
What? Oh what? Oh okay. Actually, he did that. So we do chunk indices dot count. Yeah, it works.
The only thing we need to do is we need to simply call these methods. So I'm just going to do gen blocks, then build chunk, and then all we need to do after that is render it, but we're going to call that from outside the chunk. And we're going to maybe declare this as nullable in the future, but don't worry about that. Let's see. So now let's go into our game here, and let's get rid of all of this except for the cursor state and all that. Okay, let's get rid of everything.
Need any of these at all. I'm going to save this to a notepad. That's the wrong one. I should do it.
Everything that's except for the program. So I'm gonna get rid of all this, and I'm gonna
crap. I destroyed the program. Now that should work. So I can just delete all of this.
get rid all of this except for the model view projection. Um,
Alright, so we don't need the shadow, we don't need that.
Next up, I'm going to get rid of all the translation stuff here. And we're just going to have a standard model view projection. I'm going to get rid of this program.bind. I'm going to get rid of the second draw call. And then I'm just simplifying things a little bit. And so now let's make sure that we didn't delete anything.
Right.
Get rid all of this except for the model view projection. Except I'm going to get rid of all the translation stuff here. And we're just going to have a standard model view projection. I'm going to get rid of this program.bind. I'm going to get rid of the second draw call. And then I'm just simplifying things a little bit. And so now let's make sure that we didn't delete anything critical. So let's run it, make sure. Actually, it won't work because we did delete critical things, my bad. Now what we're going to do is we're going to get rid of all of this render pipeline stuff with all this data. We don't need it anymore. And we're just going to create a new chunk. And we're going to do chunk equals a new chunk. And this is just going to take in a position. Our position doesn't matter right now. We haven't done anything with it. But we're just going to create a new vec3. Just fill it with zeros. And that should create our chunk immediately. And we do need the program, so I need to define that. So shader program, whoopsies. So now we have a program. We're not going to need this. We're just going to need to create this chunk here. So we already created it actually. We don't need to do that. I forgot. What we need to do is create a delete method. So we have good.
Wait, he's not loading the texture. Okay. That makes sense.
Memory management. So I completely forgot about that. Sorry. Let's do a public void delete. And then this is just going to do chunk vao.delete chunk vertex vbo.delete chunk uvvbo.delete and then chunk ibo.delete. Okay, that should be it.
VBO, checks VBO.delete, and then what was it? It was the IBO dot. And then we want to delete the chunk pipeline. This is so we don't have a memory leak.
It. Oh, we can do the texture as well. Texture.delete. There we go. Okay, now we can get rid of this GL draw elements, and we can do chunk.render.
Did I really do something wrong?
IBO.delete. Okay, that should be it. Oh, we can do the texture as well. Texture.delete. There we go.
Does he delete the texture? Or is that already? Oh, okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Which one is he deleting?
IBO.delete. Okay, that should be it. Oh, we can do.
Geez, he moves really fast. Do I have to do image texture.delete or no, is that fine? Is he what? Okay. Okay, so I know he deletes that.
Do the texture as well. Chunk program. Whoopsies. Create this. Is created. Let's do a public chunk. Should be it. IBO.delete. Okay, that should be it. Oh,
Geez, he moves real fast. Jeez.
IBO.delete. Okay, that should be it.
VAO, VBO, texture VBO, and then the IBO. Oh, I'm already deleting the texture. Okay.
Oh, we can do the texture as well. Texture.delete.
Alright, that should do it.
There we go. Okay, now we can get rid of this GL draw elements.
Yeah, we don't need that anymore. Because,
and we can do chunk.render, send it the program, and let's see, let's build it and see if we have any errors. 0 errors, okay. Let's see. Not set to an instance of an object. Okay. Chunk verts was null. This is correct, yeah. We didn't initialize these. My apologies. Let's go ahead and do that in the constructor here. So chunk verts equals a new list of vector3, chunk UVs equals a new list of vector2, and then chunk indices equals a new list of unset integers. Now let's run it, see if we have any more errors. Definitely do. Yep. You need to initialize the OpenGL binding first before calling load bindings. Yes. Okay. So the problem is that we created the we called the constructor of the chunk before we actually initialized OpenGL. So we didn't have a context. So that is my fault. I didn't think about that. I'm just going to define it at the top here, and then I'm just going to, in the onload here, I'm going to make sure that everything is defined properly first. Then we're going to do chunk equals the new chunk, and this way the OpenGL will be, the context will be exist before we do that. And now we have one more error, attempted to read or write protected memory. So let's see what this is. Often an indication that other memory is corrupt. Interesting. Alright, so I found the error. It's pretty stupid. I forgot to bind the chunk.
interesting. Okay, so he's got the render. Oh, yeah, that's right.
IBO. So now if we run this, what we can see is if we turn around, we have our
Good binding of creative. I just did that. What? Z what? I just did that. And what error? What line? Okay, so it's under the renderer. Oh, okay, that's why. There's a chunk. Oh, okay. There it is. It doesn't look great. Okay, it's half working. Okay.
block faces all drawn with one draw call. And it's only one because we only drew the front face, but we can definitely go ahead and draw the entire blocks this way. So for this, let's just go ahead and do what we're doing here, but for all of the faces. So we could do this programmatically, or we could just do it on top of each other. I'm just gonna, for simplicity, just do them one by one by one, and then show you the better way in the next video. So here, what we're just going to do is we're just going to add the range of this 6 times. So 2, 3, 4, 5, 6. Actually, we don't want to do that. What we want to do is we want to do this, the entire thing. 2, 3, 4, 5, 6, and then I'll do left face data, right face data, back face.
That's... Can I... No, I can't do that. Okay. Left, right. Oh, wait, no.
Face data, top face data.
Face data. face data, and then bottom face data.
And then bottom face data. And then just change these appropriately. So left, right, back, top, bottom. And since we're adding 6 face.
My gosh, Jesus Christ, this is hard. Intelligence, will you give me the... No, you... Okay. It's not that smart. Top. And we can just... No, it's still not smart enough.
Is per per block. We are now going to change this from a 1 to a 6, and
Front. So left, right. He's doing this in no particular order, so I don't really know what's going on here. Top. And bottom.
then we're also going to change the correct, use the correct variables for these. So right face, right face, right face, back face, back face, back face.
Oh, you can double click?
Front,
I didn't know that.
top face.
Oh yeah, you
bottom
can.
face.
Just
okay. Now if we run it, oh, now we're inside of a block here. As you can see, we have our 3 blocks using this method here. And what you'll notice is that inside these blocks, we are drawing every face, and you can see this like flickering. This is because we are drawing these faces in the exact.
Oh wait, no, because I haven't even changed this. Was it? I think it was like 6. We're drawing 6. Okay, that makes sense. Okay, here we go. Yay, we got 3 blocks rendering. I'm surprised there's no flickering in here. Was kind of expecting that. Unless it's like over this way. Wait, can I make this bigger? Oh, okay. That's wrong. Right, that works. Kind of. Yeah, that's a bit better, but not by much. Not by much. I don't know what's going on here.
Same spot. So OpenGL is confused on which one to draw. And so we're going to utilize a very simple chunk meshing here to sort of get the idea of how we can remove this. So basically, what we can do is, I'm not going to use the algorithm yet. What I'm simply going to do is I'm just going to use conditionals, just very basic conditionals for this. So what I'm going to do is, I'm going to do, at the top here, I'm going to do if I equals 0, then we add the left face, and then I'm going to do if I equals 2, since we're doing 3 of these, then we'll add the right face. And that's all we can do for this little strip here. And then now our indices are messed up. We have too many indices for what data we have. So what we're going to do is we're going to create a variable. I'm going to call this int face count equals 0. And basically, every time we add a face, we just increment face count by 1. Face count plus plus. And then since we're adding 4 here for all these, we'll just do face count plus equals 4. And every time we loop over this for loop, it's reset to 0. And so now we just pass in this face count here. And so what you'll see is, since we are only adding the left face on the leftmost block and only adding the right face on the rightmost block, what you'll see is when we run this, we're inside, but as you can see, it's hollow in the inside. And this is the basic idea of chunk meshing. So I can go in here and you can see there are no unnecessary faces being drawn here. So this is a super simple example. As you can see, the algorithms can get quite complex, as I'll show in the future. But this is the entire tutorial, I believe. Definitely a longer tutorial. Sorry about that, it's a lot to cover. But in the next one, we'll get into building a very simple chunk and using chunk meshing. So that being said, thank you for watching. Hopefully you enjoyed this.
Oh, there it is.
And with that, see ya next time. Bye, guys.
It does.
Hello, welcome to the next episode in the Minecraft clone tutorial series. Today we're going to be finishing up chunking and getting started with some terrain generation. So I've already went ahead and cleared out our little temporary chunk that we made in the gen blocks, and we're going to just simply, for the time being, create a solid chunk of blocks, and then we will do some terrain after that. So for this, we're going to be looping over all of the X positions, then we're going to loop over all the Z positions, and then we're going to loop over all of the Y positions, and that will generate a solid chunk of blocks. So in here, I will do a for loop, and this will be for int x equals 0, x is less than...
Wait, doesn't Minecraft do X, Y, Z? So, it doesn't loop it the way that he does, I don't think.
size, and increment the x. Remember that we have a size that variable that corresponds with the width and the depth of the chunk, and a height variable that corresponds with the height of the chunk. So for the next one, we'll do 4, and this will be int z.
Yeah, he does X, Z, then Y. I wonder why. I think I might know why. Because there are certain memory aspects into this. I think I know why he does this that way. But we're going to follow along here. So X is lower than size. And then X plus plus. 4. Int. Z is equal to 0. 4. Int. I don't want an unsigned integer. IntelliSense is not.
Equals 0. Z is less than size, and increment z. And then for the third one, we'll do for int y equals 0, y is less than height, y plus plus. And here is where all of the action happens. And so for now, what we're going to do is we're just going to create a block here. So block equals a new block. And this block takes in a variable, which is a vector 3. And this vector 3, for its 3 values, will be x, y, and z. That will be its position. But now we need to actually add the data from this block into the actual chunk mesh. So for this, we're going to do we're going to do var left face, because we're just going to add the left face for now, equals block dot get face, and we want faces dot left. Then we're going to actually integrate it. So we're going to do chunk verts dot add range. This will add everything from this selection here, and we want to add the left face vertices. So left face dot vertices, and then we want to do chunk UVs dot add range face dot UV. And then we simply want to increment the indices. So we're going to do the method that we did before, where we do int num faces equals 0, and then simply increment the number of faces here. So num faces plus plus, and now we will do a call to add indices and send it num faces. And now what you'll see is that if we run this code, we should see the left face for
Oh my gosh. Oh, oh my gosh. Oh my gosh. Oh my gosh. That's menacing. That looks menacing. Dude. Oh my gosh.
an entire chunk of blocks. that is 16 by 16 by 32. Okay, that's cool. So let's add the rest of the faces. I'm gonna make a convenience method to make this a lot simpler, so I don't have to do this code here 6 times. So instead I'm just gonna go down here and I'm just going to do a public void, and it's going to be integrate face, and then this is going to take in the block and then the face. So face is face. And then what we'll do here is we'll simply say var face data equals block.getFace, and then we'll send in the face as our as the face that we want. And then what we'll simply do is we'll do chunkverts add range, and then we will send the face data vertices, and then the chunk uv, just the same thing we did before. We're just doing it. Inside of a method, so we can shorten the code a lot inside of the gen chunk, which in a bit you will see that is very, very useful with the size of this. And so with this, that is all we are doing there. And so now instead of doing all this stuff, we can instead just simply do this. We can get rid of this. We'll do integrate face, and then we want to send it the block, and then we will send it the face that we want, so faces dot left, and that does the exact same purpose. So now we can go in here and we can turn around and we have all of them. So let's go ahead and do this for all 6 faces. So I'll just take this and add 6 of them, then do faces dot right here, faces dot top, faces dot bottom, faces dot front, faces dot back, and then just increment the number of faces by 6, because we're adding 6 faces to our chunk for each block. So now if we run it, we should see that we have a solid chunk with all of the faces in it. So let's give some height, some varying heights to this. Let's give it some terrain. So for that, let's go to the NuGet package manager.
Actually, this has given me an idea. If we just return an integer, and then we'll just return 1 for now, but when we actually implement this, since I'm going to be requiring custom block shapes, there's going to be more than 1 face. Well, more than 4 faces, or 6 faces, I think. And then, yeah. So, but for now, we'll just return 1, and then what we can do is we can just do num faces plus equals, like literally that, and that will work. Hopefully that'll work. Yeah, we got a solid chunk of bookshelves. Okay. But the only unfortunate thing is everything's being rendered inside, so it's a bit. Does it look like Java Edition? Oh, it looks like Java Edition. Unintentionally. But, okay. There's not much I can do until I code the shaders in, but
Manager or package manager. I don't know if it's NuGet or Nugget actually still, so maybe let me know in the comments. So you're going to be looking for simplex noise. It's the one at the time of this recording, it has 9,000 downloads. It has a blue S logo, whatever. Just download that. It's a pretty small library here, so it's pretty nice. And what we're going to be doing is we're going to be generating a height map for this. This isn't going to have any fancy caves or anything like that. That's not for this episode. This is getting some basic terrain generation up and running. So we're going to use this gen chunk here. And the first thing we're going to do is we're going to change the return type. It's going to return a 2-dimensional float array. And here we're going to basically change that here. We're going to say float height map equals gen chunk. And it's given the seed. And I'll just do this just to show you that you can do it. 0, x is less.
We don't have to do any terrain generations in the Bedrock replay, so yeah. I'm not following along this part.
Arguments, the x position, the value that we get from this. So what we're going to do here is we'll do int, and then we'll do column height, because it's the current column's height. And since this is a float array, we're going to actually have to typecast it into an int, and then we're going to do the height map generated here. So there you go. That's some decent
That's some
terrain
interesting.
generation. So I know that it's all dirt. We'll get into multiple different block types in the next tutorial. The problem is that we are loading every single face for every single block inside of our chunk. And while this doesn't have any performance issues when we have one chunk, if we are loading in 100 chunks, dramatically can decrease in performance. The only real blocks in that example that we had to render were all the ones on the outside. So all of the inside blocks or all the inside faces could have just been removed and the player would not notice anything. And this is the basic concept of chunk meshing. When the whole purpose of us creating this chunk mesh, merging them all into one, while it does make it only one draw call, another benefit is that we can specify which faces we want to keep and which ones we want to remove, which can greatly increase performance in the performance demanding genre of voxel game development. And so for this, we're going to actually create a new data structure here. And this data structure is going to be a three-dimensional array of our blocks. And so we're going to do a block, and this is going to be a three-dimensional array, and this is going to be chunk blocks equals a
See what? Just
new block, and then we're going to have it of size. This is going to be X, Y, and Z. So we're going to do size, height, and then size here. And this will be all of the blocks inside of here. Now, for this to actually work, we're going to need an empty block type. So let's go ahead and do that. Let's just go in here and let's create some block types. So I believe we haven't done it before. Let's just go here. Let's create a public enum. And let's do block type. And for this, we will have a dirt one, and then we will have an empty one. And go ahead and go to our block here. And now when we construct our block, we're going to add another argument. And for this, we're going to do block type, and we could set it to a default value. I'll do a default value of empty, and I believe that should work perfectly fine.
oh, he's in his block class. Okay, so we go. We just do type. Is it going to be type.air?
Fine, yeah. And now all we have to do is just assign our block type to this. So we will do public block type, and then we'll do type here. And then we will simply go into our constructor and we'll say type equals block type. And now what we're going to do here is we are going to change up some stuff in our And now what we're going to do here is
I actually don't care if there's like a thing. It has to be private, isn't it?
we are going to change up some stuff in our chunk. So instead of just creating the block as we do, we are going to add one more little thing here. We're going to do chunk blocks. We want to declare the chunk blocks outside of the constructor here. I've been coding a little bit too much in Python recently. Okay, so let's go ahead and just go down here and I'll just put it here. And what we'll do is inside
Okay.
of this generation here, we will do chunk blocks, and then what we will do is we will do at x, y, and z equals block, or equals, yeah, block. what we're going to do is we're going to do one more check. So you'll notice that we're passing in the block here. However, we need to do a different check here. So we're going to revert this from column height. We're going to instead just use the max height here. And then what we'll do is we'll do if, and we want to do a check here, and we want to do if y is less than, and we want to do column height here. If it is less than, then we will do all of this. Otherwise, we will simply, so we need to do a little else here. We will simply add a column block, or we will add to the chunk blocks here. So chunk blocks at XYZ equals a new block. And this takes in the two arguments. So the first one is the new vector 3, which is the x, y, and z. And then the second one, we will do block type dot empty. And here we are actually going to specify block type dot dirt. And so now what this is basically saying is that we are looping through the entire size of the chunk, and we are looping through the entire height. But if the height, the current y of this for loop is greater than the column height that's generated by our height map, then just put an empty block in its place. And you'll notice that we are not adding the faces of our empty block here because we don't want to do anything with this empty block. It's simply a representation of a block. And so now that we have this, we can get into some more stuff here. So what we're going to do now that we have this all set up is we're going to move where we are adding our faces to a separate method. And so this is going to be a public void gen faces. And this is where all of this logic is going to be. So we're going to do another for loop. And this is going to be the same idea. So just a looping over the x and then looping over the z, making sure that it is size, not height, and then looping over the y. And now we are doing this extra loop here, and we are going to do this. So we want to get rid of the faces that are not wanted here. So we're going to get rid of this first, and we are going to make this a little more efficient. So I'm going to put this on one line now, and you can see that that makes that a lot more efficient. We're going to be doing the face adding logic in the gen faces, which we are going to call after this. So we will simply call after gen blocks, we will gen faces. Let's go to the gen faces, and now let's have some checks. It's on one line now, and you can see that that makes that a lot more efficient.
Hmm. No idea what I'm doing here.
We're going to be doing the face adding logic in the gen faces, which we are going to call after this. So we will simply call after gen blocks, we will gen faces. Let's go to the gen faces, and now let's have some checks. So let's do the left faces first. And by the way, little disclaimer, this is not going to be the absolute most efficient method. This is something that is a little bit simpler to understand, a lot simpler to understand than things like awk trees and like greedy culling and all that stuff, or greedy meshing, sorry. So this is going to be a little more simple to understand. So that'll hopefully clarify some things. We're not making a super ultra optimized version from the get-go. So what we're going to do is we're going to do the left faces. And so what is this? So the qualifications for the left face. So the qualifications are going to be the block to the left is empty, and that is it. So let's check here. And we'll check that is not farthest left in chunk. So the left face follows the x-axis. So what we'll do here is we will simply do if, and we will do x is greater than 0, and now we do the check. And so this will be the check here. So what we're going to do is we are going to do if, and then we need to do chunk blocks. Whoops. If chunk blocks at, and then we need to do x minus 1, y, z dot type does not equal, or actually equals block type dot empty. If it is empty on the one to the left, then we want to add the left face. So we will do integrate face, and then we will do the block, and the block is going to be the chunk blocks, chunk blocks at x, y, and z. And then it's going to be the face, so faces dot left. And then we're going to add an else statement to this if x is greater than 0, because if it is not, that means it's on the farthest left. So we
Uh,
we will just simply add it without this check. And so what we'll see with this here is that we should generate only the appropriate left faces. And we go over, and it seems like that did not work fully. So let's check. I completely forgot. We need to do this. We need to do int num faces equals 0. And then we need to increment here. So we need to do num faces plus plus, num faces plus plus. And then we need to simply add the indices and send it the num faces. This should fix our issue. All right, so we are seeing all of the left faces, although I think we are actually seeing the ones that we shouldn't see instead of the other way around. So that actually shows that it kind of works just in the opposite direction. So I think the reason is because of the issue here. So yes, what we need to do is this. The first thing that we need to do is we need to change this height to the column height. I forgot about that. So we'll do int column height equals height map equals our height map. We need to actually send the height map again. So float height map equals the int typecasted version of our height map at x and z. Whoops, it is our chunk is on a while loop to go up to only the column height. I believe that should remove the ones all the way up there. I need to send the height map here. And now if we look around, we should see that we have one pane, and this is because I think our chunk is on a slope in the opposite direction, so there actually aren't any other necessary left faces. Let's make sure by adding our right faces. So let's add our right faces real quick. Let's go to these right faces and let's do right faces. And the qualifications are the same thing, except just block to the right is empty, and it is not the farthest right in the or is farthest right in the chunk. I should change that, yeah. So now what we're gonna do is we'll literally just copy this over, and what we'll do is we'll do if x is less than size minus 1, and this means that it is not the farthest right. Then we need to do if x plus 1, and this should all work fine here. So what we can do, actually, yeah, this should work here. So now what we can do is we can run it and see if this will work. We need to do faces.right though. And faces.right. We might get an error with that size minus 1. It might need to be size minus 2, though I think that should work. Yeah. Now we can see all of our right faces have been added in correctly. So this is everywhere where a right face appears inside of our chunk. So nice. It's a nice little, it's cool to visualize this. See how many faces do we actually need here. Okay, so now let's handle the top faces. Top faces. Now the qualification, let's go here and let's copy it down. The block to above is empty, and the farthest or is the farthest up in chunk. And so we can do this, and we can simply say if, and we want to do y is less than size, or not size, y is less than column height minus 1, else add it. So just simply add it here. And then otherwise we can do this check here where we do if chunk blocks at x, y minus 1, or y plus 1, my apologies.
Oh, that's gonna be a bit of a pain, isn't it? Okay. Oh wait, but that's terrain generation. It doesn't necessarily mean that it's actually. I'm still confused though, a bit. Um, Honestly, it shouldn't make too much of a difference though.
Apologies. And z
So should have hello.rex. Um, right, home faces. This has to be the top. Top. See if that works. Yeah, there we go. Oh my gosh. It's a big block at the moment. At least we're getting there. We're getting somewhere.
dot type equals block type dot empty, then integrate the top face. Now if we run this and all goes well, we look over and we see our top faces, every single one of them rendered properly, and we have no extra top faces. So that all worked perfectly there. Let's render some bottom faces. So let's do bottom faces. And I know I'm walking through all of them, but sometimes it can be a little bit hard to think about one for a bit. So this means that the block below is empty, or it is the farthest down in a chunk. And for this, we can reverse our top face, copy and paste it. If y is greater than 0, then we will simply do this, and that should be it, except faces.bottom, faces.bottom, run it. And we look over, we have our bottom piece here. And while there are a lot of, this isn't perfectly efficient because you don't actually need to render the bottom, I'm just showing a general example. We can get into extreme optimizations in future episodes. Let's do the front and the back to complete these blocks. So the front face. Now the front face, I believe that the front face moves negative towards us. So what we're going to do is we're going to do if, and we will do z is, and then we need to do left.
Isn't it positive? Oh, okay, so positive. No, hold up. No, that's not how OpenGL works. You made a mistake there.
Yes, then, and we need to do size -1. Then we will simply check here. So we'll do if, and we'll do chunk blocks at x, y, and then z.
See if that works.
+1 dot type equals block type dot empty. We're getting an error. No, we're not. And we simply need to do again the integrate face in the chunk, faces dot front now, and then else we simply integrate it again there. And now let's do the final one, the back face. Copy and paste this. Change.
If I'm correct, this should be wrong. Yeah, it's wrong. So you did that wrong. Oh wait, no. I did it around the wrong way. Okay. Okay, there we go. That worked. That seemed to work. Now, of course, we do the back faces. It's higher than 0. So we're looking towards us. We're looking away from us, or from the camera. And that should, in theory, create this chunk correctly. Yeah, there we go. If we go inside it, it's empty. Yee. I wonder how many vertices. It's working. It is working. Oh gosh. The wow effect. Oh, wait. There's a render distance. I did not know that. Okay. I really need a speed changer. Okay, there we go. Oh my gosh. Some of this mouse thing is not working, but okay. Hey, look, it's working though. Cool.
Change this to z proper chunk meshing. So thing and all the chunks, and you don't see these blocks here, and the reason is because it uses backface culling, and so we're going to be using some backface culling here to ultra optimize this. And so to do this, it's actually insanely simple. All we have to do is we can simply go to the on load here, and where we are enabling the depth test, we can do the gl dot front face, and we're going to change the front face direction to clockwise, since we created ours with a clockwise orientation. If you did not, if you did different vertices, check which direction they are going in your indices, because by default it is counterclockwise. Now we need to do gl dot enable, and this is going to be the enable cap dot cull face. And now we need to set the direction, so gl dot call face, and we need to do call face mode dot back, and that is it. So now we can run it, look around. Actually, we're inside of it. That's why that shows that it worked. We are here. We can see everything outside. We can see all this, but if we go inside, we can't see these blocks because they are in the back side. We don't see the back faces of blocks. So we have gotten ultra optimized here. We are only rendering the absolutely necessary block. And so, yeah, that's it. That's basically the...
I think I did it wrong. Oh gosh. I 100% did this wrong. Um, why is it not working then? So if we're over this side, yeah, that is odd. That should not be happening at all. I think I did this round the wrong way. Oh, I think, okay. I'll have to check his thingy. Okay, so where is it? He had... Alright, I have to check his stuff. Integrate face, no. No, okay. I think that's the end of that.
Side, we don't see the back faces of blocks. So, with that being said, thank you very much.
Alright, so I'm gonna go... Nope. Further back. I'm gonna have to check his... There we go. If we can find it. So, under the... What is it? The world? Under the block data. Okay, so this is against mine. So, if we check against mine to his, so I know I have the front faces correct. Because otherwise it wouldn't be rendering in the way that it is. Then we do the back faces, which is wrong, I think. Yep, there it is. There it is. So that's... okay, so yeah, I am doing this the wrong way. And then this is negative, and then these bottom two are negative. And the left side is negative, and then this is the wrong way around. Then, of course, the right face, 0.5, 0.5, 0.5, negative 0.5, yeah, that's correct. That's correct. I think it was only two faces that were incorrect. Nope, never mind. This face is also incorrect. Right, I believe that should work. There we go. There we go. That makes things easier. If we go inside, we should see nothing. So yay, we've got something working. Mince raft clone. No, just kidding. He has another tutorial. Not sure if I'm going to do that one. Could have done today. Maybe. Am I? Alright.
Hello, welcome to another Minecraft video. Today we're going to be adding different blocks to our world. So if I run our previous code that we made, you'll see that we have our simple chunk of all dirt blocks, and we're going to be adding grass to the top of this chunk in this video. So let's get into it. The first thing we're going to have to do is add a block type to our enum of block types, and we're going to add grass here. And the next thing we're going to do is we're going to be changing the texture that we're going to be using. Up until now we've been using this dirt text.png.
Ooh, actually,
This dirt text.png is just the dirt itself. We're going to be switching to using a texture atlas, and I don't remember if I gave it to you guys in the beginning, but this is the texture itself, and it's linked in the description. What it's
okay, hold on. Hold on. Does Bedrock samples have it? Because I know that when I create mine, I'm gonna have to have a texture packer, and it's gonna have to generate the atlas. But for now, but that's wrong. Oh my gosh, that is a lot of PNGs. The only problem is it looks like there is no texture atlas. It's sad. That is really sad. Are these? Okay, yeah, they're that thing. Okay. Um, what about map? No. As you can see here in the paintings, they're actually using a texture atlas. The only problem is mine, well, they generate their own texture atlas. So, this is where things get a bit difficult for us. Wait, hold up. They have a sprite sheet they of course have a sprite sheet of the UI. Um, but yeah, I think that's how that works. And then they just overlay the missing texture onto blocks that don't have the texture atlas or something like that. I think it's like that, if I'm correct. Oh, they have the trim. They have the trim stuff on here. I did not know that. Oh, well, enough about this. Terrain texture. Okay, so they have terrain textures, but then they have a block texture. Which, hang on a minute. So they have blocks, and then under the textures, they have terrain texture.json, and these define each. Oh, I know how this works now. It still doesn't make much sense, but okay. So at least you left this in a link just below, so I can just download this. Um, go see VS projects me. Nope, I don't want voicecraft. I want. Where's it gone? Oh wait, I think I know where it is. Textures. Then we have the atlas.png. All right, that'll do us for now. I am going to include this into the build. So we're going to have to change this, and we're going to say copy always. And then shelf. Copy if newer. Actually, we're going to do that just so it doesn't always do something. This just prevents the build from actually destroying us. And then hopefully that will do it. So
is basically, it's also known as a sprite sheet. It's just a texture that contains a ton of different subtextures. And so what you do is you actually only have to bind this texture once, and then you can just specify the coordinates of each texture on this atlas. This makes it really a lot more efficient when doing a game like Minecraft, where you have a ton of different textures. Instead of having to bind and unbind each texture for each block, you can instead just do this. Okay, so now let's go ahead and get into this. So what we're going to do here is, the first thing we're going to do is we are going to add a new class in our world folder here, and this is going to be the texture data.cs. And this texture data.cs is going to be a static class. And for now, it's just going to contain one data structure, and you have to bear with me here because this is a huge data structure, but it is necessary for organizational purposes. So just read along and I'll explain it. So we need a public static read-only dictionary, and the key value is going to be the block type, and the...
We have it in the world? I wouldn't put it in there. I'll put it in my textures thingy.
value is going to be a subdictionary, so a dictionary, and the key value is going to be faces, and the value is going to be a list of vector 2s. Okay, and I'm just going to call this like block type UVs. They're going to be equal to a new, and it autofills for us, thankfully.
That is one big constructor, dude. Block UVs. Okay, so this is exactly the classes I need. I don't need to write anything else except for when I add certain things. Oh my gosh, luckily he covered this part because I was going to have to figure this all out by myself. And I did not want to do that, so.
We're going off screen with one variable declaration, so that's great. And this is our variable. So what this is going to do is it's going to store the texture data for each of our block types, and it's going to store it in a dictionary of each face in the same way that we did it with our vertices here, where we have a dictionary with our faces for each different vertex. And this way we can specify which UVs we want to actually add. So let's add one for our dirt. Since we're using our atlas here, the dirt texture, or the dirt UVs are actually going to change. This is now over here instead of the entire face. And we have to take into account a couple things before we make these coordinates. One, in our texture class, we are flipping the vertices, we are flipping the image on load, meaning that our coordinates are inverted. The second is that our texture atlas itself is 16 blocks by 16 blocks, so meaning that our coordinates are going to be out of 16 blocks. So now let's go ahead and make some data for this. So for the first one, we're going to have to specify a block type dot dirt for our original one, and then for this we're going to make a new dictionary.
I'm going to add in a dirt block, actually.
Of faces and lists. Okay, and then here we're going to add our first one, which is going to be faces dot front, and this is going to have a key value of a new list of vector 2, and this is going to have a some stuff in here. And so for this, I'm just going to go to our block and take that data that we have already, copy it and paste it. We're going to
Okay, I did that wrong. I think I did that wrong. What's going on here? There we go, that seemed to work. There is no argument given the required value of the list vector 2 base. And faces list vector 2. The what? Okay, that is a lot of constructor things. I do not want to deal with that, actually. What? Okay, so we'll put that there, so that lines up to that one. This one lines up to this one, and that one lines up to that one. Okay.
What we're going to do is I'm going to adjust it to where it needs to be. So the dirt in our atlas is over.
Okay, so we just say alright, so where is our atlas thingy? Where is our Okay, oh, he has that. Okay.
We have already, copy it and paste it. What we're going to do is I'm going to adjust it to where it needs to be. So the dirt in our atlas is over 2 and up 15. And we're going to do the bottom left, bottom right, top left for our texture. So let's go ahead and do that. So it's going to be 2f divided by 16f, and then it's going to be 15f divided by 16f. And then it's going to go over to the bottom right, so it's going to be 3f divided by 16f, and it's going to be 15f divided by 16f. Then for the next one, it's going to be again 3f divided by 16f for the top right, and now that we're at the top of the texture, we just do
Okay, I don't understand what's going on here.
1f. Then it's going to be 2f divided by 16f for the top left. So now what we have to do is just add a comma here.
Oh, that's the first position, then we scale it up. Okay, so, oh, I'm confused. Can you just specify 2 points, or do you need to specify 4 points? I'm not entirely sure. Let's do 3f, 16f. That's wrong. Alright, so how do you explain this? This is what I want to understand.
A new dictionary. First one that we have already, copy it and paste it. What we're going to do is I'm going to adjust it to where it needs to be. So the dirt in our atlas is over 2 and up 15. And we're
So over 2 and up 15.
going to do the bottom left, bottom right, top left for our
So bottom left, bottom right, top left, top right.
texture. So let's go
Top
ahead
right,
and do
top
that.
left.
So it's going to be 2f divided by 16f.
So for over, okay. Let's take a look. Can I please get a better view of this? I don't want to. Can I zoom out, please? How do I zoom? How do I zoom out even further? Does it doesn't give me a That's sad, dude. Oh my gosh. Okay, well, at least we know what we're dealing with here. So, because we're inverted, that means we need to go up. What up? So we're going what? 2 across divided by 16. So we're going what? Like, so we're going. Yeah, I tried that. It didn't seem to work. So 2 across. So we're going. So we're going 1, 2. So we're going like pretty much 2 across divided by 16, which is the size of this. Oh, wait, no. Okay. So we know that textures are 16 by 16, right? So we know that each texture is 16 by 16. So we're going 2 across. So we're going 2. I'm confused. How big is this atlas? 2048. Okay, so, 2048. So we're doing 2 divided by 16, which is going to go here. And then up to what? 15F, 16F, which means it goes from the bottom. So that goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we're up to 15 here, which is... Okay, yeah, that makes sense. So this is the 15th block here. Then we're going bottom right, which is here, which is the same thing. So this is basically 3F. So we're starting on this point here. So we're ending on this point here, on this pixel, like right between this. And then we say we want it up 15F, so that's the same point, which is right there. Then this is where, okay, so we're at 3F, so that means we're on top of here. Then we go 1F, which means we're at the very top. We're at the very, very top. Okay, so I think I understand what's going on. So, um, basically what's happening is this image is in float data is actually, well, in float data, it's actually 0, between 0 and 1. So as you can see here, so on this point here, this is 0, this is 0, 0, and then this is 1, 1 up here. So what we're doing is we're just picking these pixels out using float data. I think that's what's happening. Hopefully that actually does sort of understand. Because if we pick a different texture, I'm going to follow that same process and see if that actually works. So we're just, and then this is 16F is actually the pixel size. So and of course, if we were to do like 16 divided by 16, that's equal just to 1. So there's no point in just saying 16 divided by 16. So I think that's what he did there.
F, and then it's and because our dirt is the same for all of these, we don't have to actually change anything. But the grass is going to be a bit different.
Right, so Oh, thanks a lot, dude. Why is this not copying? Front, uh, left, right, top, and we say bottom. Alright, so at least this gives me a blueprint of what I should write in for, well, what I should handle for the block data, I think. Well, I mean, like, as in, how do I explain it? The, freak, I forgot what it was called. Like the U.
Let's first get this new system working with our existing chunk here. So we have to go to our block for this. So we're going to completely change this. Actually, we're going to create a new public dictionary of, and this is going to.
Wait, did someone donate to me? Wait, hold up. Why didn't it pop up on my stream? I'm gonna check it real quick. Oh my gosh! Yeah! Thank you to the person who donated. Oh my gosh. Oh my gosh. Wow. Oh, wait. Net. Oh, okay. Yeah, it did pop. Oh, wait, hold on. Oh, give me a second. Is this public? Just before I can say anything. Um, just a quick question. Right, let's check. Oh my gosh. Thank you, Net. Thank you so much, Net. Oh, thank you. Oh my gosh. Jeez. I really appreciate it, man. I really appreciate it. Ooh.
To be a key value of faces and a value I keep on saying that, of list of vector 2s.
What am I doing here? I forgot what to do here. So it looks like what we
Public dictionary
okay, so
of, and this is going to be a key value of faces and a value I keep on saying that, of list of vector 2s, vertices, or not.
Oh wait, he made these public? Okay. I thought he made them private first. Okay. Looks like he's gonna keep them like that, so public dictionary faces list vector 2 uh vertices.
Not vertices, it's going to be block UVs.
Oh wait.
And then what we're going to do is we're going to have a check here. We're going to say if block type does not equal block type dot empty.
Oh wait, no, if type is not equal to type dot air.
Because if it's empty, we don't want anything. Then we're going to say block type equals, then we need to go into texture data. So texture data dot block type UVs at block type. And so what is that going to be? We're getting an error here, so we can't convert it. I need to actually make it block UV. That's my bad. We now have this block UV, and what we're going to do is, instead of just assigning this dirt UV for all of them, we're going to do block
Um,
UV, and then since this is the, so we can't convert it. I need to actually make it block UV. That's my bad. We now
oh, whoops. Hey. Okay, so
have this block UV, and what we're going to do is, instead of just assigning this dirt UV for all of them, we're going to do block UV, and then since this is the front face, we're going to do dot or at faces dot front, and you can see that that now goes away. And this says block UV may be null here, but it won't. It's fine because it should just equal. Oh, we need to make it equal to a new dictionary. There we go. That should work now. So it's not going to be null. It's just going to be empty. So
interesting. So UV is equal to text UV, and then we say faces dot. Oh, whoops. That's wrong. And this doesn't exist. I'm not sure what I'm supposed to be doing here. Oh, okay. Text UV, text UV, text UV, text UV. So we're doing front, back, left, right, top, and bottom.
So now we need to do front and back here, and then we need to do left here. Since we were adding them all, we need to do right here, and we need to do top, and then we need to do bottom. Okay, so now we're just assigning the appropriate UVs from here. So we're assigning the front to the front, back, left, etc., etc. Now what we're going to do is we're going to go into our chunk and actually get this all working. So it should work right off the bat, actually. So let me just go ahead and test it real quick. Just go ahead and do this. And we do actually get an error. The given key front was not present in the dictionary. And I was expecting this. I think the reason is because we actually do need to provide it in the beginning. And so what we'll do here is we'll just do we'll just do the fake empty key values. So faces dot front, and then just a new list of vector2, but like nothing in it, you know. And then we'll just copy this down 6 times: front, back, left, right, top, and then bottom here.
As an object. Okay, so object up front, and then we say new list vector2 like that, and then of course that's not going to work until we do that. Then we need a semicolon there: front, back, left, right, top, and then and we don't need this trailing comma.
That should make it so that we can use this without getting those weird errors. Okay, and we look back and we have something really weird. And yes, I forgot to actually change the texture. Let me go back to chunk here and let me change the texture to.
See what? The given key was not present in the dictionary. One moment. Alright, let's see. Okay, I think I know why. Right, so looks like we have got our block type wrong, and we want block type of dirt instead. So we have to go here. Oh wait, no. We're generating the wrong block. So we want the, what is it? Um, so where's our chunk? So a chunk here, but we're generating the blocks a bit wrong. So I think we need to generate blocks. Yeah, there it is. Okay, dirt. Hopefully that'll work. Okay. Why did this destroy itself? Honestly, I should wrap this in a dry catch, but we'll do that later. For now, I want to change this reference. So we've got less. That means we only need to bind once, and we should see a big block of dirt. A big block of dirt. Hey, it's working. Hang on.
From dirt text.png to atlas.png. So now we're using that giant texture atlas. Now if we go back, there we go. Our dirt looks exactly as it did before. Cool stuff. Now we have to add grass. And for this, we have to fix a couple errors before we do this. So in the chunk, what I did by accident is I actually only looped through the column height, which is the height map height. This is not accounting for any like empty space at the top. So I'm going to change that a bit. I'm going to just get rid of this completely. And I'm going to just change this column height. So we're looping through all of the Y positions up until the height of the chunk. And then we're going to have one check that's going to be crucial. So we're going to do if chunk blocks at XYZ dot type does not equal block type dot empty. Because there's no point in doing all this if the...
Oh, okay. So yeah, I'm gonna hard code the air block because there's literally nothing. It's literally nothing. So I'm gonna do that. And then of course we're gonna have to so if chunk blocks dot at x y and z. We're gonna have to change this into a flat array for efficiency, but for now it will work. Dot type is not equal to block type dot air, and we'll just say
block type is empty, and then simply take this entire meshing algorithm, if you will, and just cut it and then paste it inside of that to make sure that we're only accounting for that one. And then we need to change a couple things. So instead of doing if y is less than column height minus 1, we do if y is less than height. This is for our top check here, and that should fix things. Just to make sure that this is still working, let's go ahead and run it. We zoom out, and we have the exact same result. And we go inside, and we have the exact same thing. Cool, that's all working now. Now let's add some grass. So for this, we're actually going to zoom out a lot.
oh wait, no. That's the wrong way around. Okay, there we go. Now we've got the right way around. Mince raft clone. I have to still implement the shaders, like the Bedrock shaders. I'm not sure how I'm going to do that because I can just copy the shaders over, but how they work, it actually depends on certain things. So.
And we're going to be adding a new one here. Now you can definitely see that this is a bit inefficient, pretty inefficient actually. And the way we could fix this is by simply providing like coordinates for our block. But I think I will work on efficiency in like the next tutorial. So I'm going to just duplicate this here. I'm going to press enter here. The idea is that this will work as a little running example, and then we'll get into a way of fixing that, making it more efficient, you know. So for this, we're going to do block type.grass, and then here we are going to simply shift over it because the grass is over here. Now the top face is actually going to be over here, and the bottom face is going to be the dirt itself. So for the top face, we will just ignore it for now and make sure this is actually working. Let's first do this. So 3F, 4F, 4F, 3F. That's for the front face. So for the front, and then just copy it for the back and the left and the right. And then for the bottom, we can keep it the same. And then for the top, for now, we'll just keep it as dirt. Actually, we'll put it as the side facing grass to make sure that we got this working. But then we'll fix that in a second. Now let's go to our chunk and actually add some of these. 4F, 4F, 3F. That's for the front face. So for the front, and then just copy it for the back and the left and the right. And then for the bottom, we can keep it the same. And then for the top, for now, we'll just keep it as dirt. Actually, we'll put it as the side facing grass to make sure that we got this working. But then we'll fix that in a second. Now let's go to our chunk and actually add some of these. So what we're gonna do is we'll just do, we'll only add dirt if this is equal to, or is less than the column height minus 1. So what we'll do is we'll actually do block type equals block type dot empty. And then we'll do is we'll simply just have one statement at the bottom here that does this, and we'll just say we'll just, instead of adding our block type here, we'll just add our type here. And we'll just say if the column height is less than, or if y is less than column height minus 1, then we'll assign the type equal to block type dot dirt, and then we'll do if y is less than or equals column height minus 1, then
one will work.
Whoa, what's going on here? Then we can do type equals block type dot grass.
Wait, is that upside down?
That should be adding our grass only at the very top, because we're only setting it if it's actually equal to that height. Okay, now we have that. We can run it. Zoom out here. There we go. Only the top of our chunk has this grass here. Now, of course, it's jacked up, and as you can see, it is actually upside down. So I got to think about why that would be, but it is working at least. So that's pretty cool. So now let's go ahead and add our grass and stuff. But first, I'm going to flip the texture data here. Not sure why, but I'm just going to take the bottom two and put them at the top, and then just take this.
Oh, you can flip them by. What? You can actually flip them by like that? I did not know that. Dude, that is insane. Oh, that is so much easier than high level. Oh my gosh. That is so much easier than having to deal with the high level stuff.
And put this here and see if that works for this. It should, but let me make sure. We might get something funky. No, there we go. Now our sides look normal. So now we can just fix our top face. Okay, so for the top face, let's look at our coordinates here. In the atlas.png, it is over 7 blocks here, and it is down 3. So it is actually at 7 and 12. So we can use that as our starting base. And so, okay, so let's do that here. So we'll do 7 for the bottom. This is the bottom left here, the bottom left, and this is the bottom right. So it's going to be 7, it's going to be 8, and it's going to be
Wait, what was it? 7, 8, 7.
7 and 8. And then for this, we're going to do 12, 12, and then 13 out of 16 for these. You can get the idea. It's just like a coordinate system, kind of. That should work right off the bat. We go up, Oh, no, it did not. We have an empty one, so let's check why that is. So we went over 7, and then we did 12 and 13, um, which is not what that is. That is 13 and 14. Okay, okay, that's just math issue right there. That's a math issue. 13 and 14. Okay.
Yeah, I see what's going on here. I definitely see what's going on. Yeah, we got grass. It looks old, but it works. Also, what the? Why are there certain things?
Not good at counting apparently. There we go. Now it should be fine. If we go up here, yeah, there you go. There's your grass. There's your Minecraft looking grass there. All looking cool. And so I know I said that I would make it more efficient in the next tutorial, but I think that I'm actually going to do that now because this is wildly inefficient, and looking at it now, we definitely adding 3 blocks is already getting crazy. We're already at like what 100 lines of code with, so let's go ahead and change that. What we'll do is we'll actually just leave this here just in case this completely fails, but I'm going to create a new dictionary here, and I'm just going to create a public static, and it's going to be a dictionary, and then the key value is going to be the block type, and then the value is going to be a vector2 coordinate. So I actually didn't think about this, but for the ones with multiple blocks, we can't make it that simple. I thought it could be that simple, but it can't. For the value, we have to make a new dictionary, and this dictionary will have a value of faces, and then a value of a vector2. Okay, and then we can just replace that with that. Okay, so now let's add our faces here. So for the first one, we'll do block type dot dirt new dictionary, and then we'll do faces dot front. Oh wait, it is a dictionary, so faces dot front equal to a new vector2. For the dirt, it is at I think it was 215, right? So 250, or no, yeah, 215. So we can just do 215 here, and then we can take this and use it pretty easily. So cool. So now we can add our
What did you do? Okay.
other faces in. That is insanely more efficient.
Mm, am I doing something wrong here? Oh yeah, I'm doing something wrong here. I think I'm doing something wrong here. Help me out. Um, cannot convert. Oh, okay, so I've got a conversion. Incorrect conversion. There we go, that must need to work.
Okay, faces dot left will have the same thing. Faces dot right, faces dot back. I should mention that the order doesn't matter here because it's a dictionary, and dictionaries use hash maps to search. It doesn't matter about order. And so they're all the same for dirt, so this should be fine. And so what we'll do is we'll just have a check and then just see if we can get this working with dirt. So we'll just do here else if equals block type dot dirt, or actually we can do not else if, we can do block type equals dirt at the top here, and then do else if for this one. So else if here, and then here what we'll do is we need to actually create a new method here, and this method will simply add our appropriate UVs. So this will be a public, and this will be a dictionary of faces and then a list of vector 2s, and this will be get UVs from coordinates, and then this will take in as an argument, it will take in a dictionary of faces and UVs, so a dictionary of faces and then vector 2s, since there's only one vector 2 coordinates. So what we can do is we can simply say that if this equals dirt, then we just do block type equals get UVs from coordinates, and then we need to send in the dictionary here. So what we'll do is we'll do texture data dot block type UVs at block type. Oh wait, not block type UVs. Dot block type UV cord at block type. And so, oh, and we also need to change this to block UV. Here we go. Okay, that's why. All right, so now what we're doing is we are taking this new, better formatted data, and we're sending it in, and what we're going to do is we're going to just take this coordinate and we're going to expand it for each of these. So this is addressing the bottom left, of course. So what we'll do is, that's why. All right, so now what we're doing is, and then we'll do a var, and this will be our face chord in chords. This is going to be the key value pair, and then what we'll do is we'll just need to create our new dictionary up here, and so this will just be this one. So face data equals a new dictionary of all that. So we'll do face data, and then we need to do face chord.key equals a new list of vector 2, and then here we're going to put our 4 values. And so remember we have the bottom left, and it goes top right, top left, bottom left, bottom right. So I'm actually going to copy this over to make it a little bit easier. And then what we'll do is, since we're doing the bottom left, we will actually just do the face chord dot value dot x divided by 16f, and then we'll do face chord dot value dot y, because that's the second value, divided by 16f. And then for the bottom right, it's actually 1 over, so it's going to be just the exact same thing, but plus 1 right here, plus 1f. And then for the top left, we do the same thing, but it's going to be
oh wait, there's only 4.
Up 1, so it's actually just going to be plus 1f, so plus 1f. And then for the top right, it's going to be plus 1 for both, so plus 1f. And then plus 1f. And then at the very end, all we do is we simply return our face data.
So we have that one. Just put that in. And we can do the same for this. This one's +1. This one's not anything. And of course we have nothing here.
This should make it a bit more efficient. And so we're only doing this for the dirt, but let's see if it actually works here. Item with the same key has already been added. Key.back. Oh, did I accidentally make a duplicate? I did. So front, left, right, back, top, bottom. Okay, there we go.
Front, left, right, back, top, bottom. Oops, that's not what I want. Okay. That's not what I was expecting. Okay.
Let's make sure that works. So get rid of this breakpoint, get back up, and this is not what we wanted. This is not at all what we wanted. Okay, so after a lot of debugging, it's actually just a PEMDAS issue, and it's really annoying. But yes, you do have to put it in parentheses, which is really annoying. So I'm gonna put this in parentheses here. So like whenever you add this 1F here, you do have to add the parentheses around it to make sure that that addition happens first, which is really annoying. But
Interesting. Well, I guess BODMAS. What is it? Or BODMAS? Something like that. Because of these things, but hey, look, people made C# like this. Can't really complain. I mean, it kind of works.
you know, PEMDAS exists, so there we go. Let me go down, man. Sometimes C# has way too many suggestions here. Okay, so that should fix it. It's a PEMDAS issue, so that should fix it. Hopefully, right? Okay.
Oh, okay. I did my thingy wrong, so yeah, we got that round the wrong way. So under what? It's under block. Yeah, we got this around the wrong way. Hopefully that works. Yeah, there we go.
Here we go. Let me go down, man. Sometimes C# has way too many suggestions here. Okay, so that should fix it. It's a PEMDAS issue, so that should fix it. Hopefully, right? Okay. Now we have our grass. Nice. So it's using this new system, so now we can do it for our dirt as well. So I'm just going to take this and copy it, paste it down here, block type dot grass. Cool, that's our grass now. So now what we can do is we can just disregard that old stuff, and then just to say if it doesn't equal empty, then we'll simply do this instead. Makes it a lot more simple here. Boom. There we go. Okay, now if we run this, we should see
down.
Our grass is exactly the same. So we made no visual progress. However, what we can now do is go to our texture data and get rid of this temporary garbage here. Just delete that all. And
Right, so we're gonna do the same thing. Like, this works fine. Where is it? Alright, so this does work fine. The only problem is the well, we can't actually change the size. So what I'm gonna do here is I'm gonna change this. So should we do a full integer, unsigned integer texture size is equal to 16. Oh wait, no. Does that have to be? We'll just make it as a float, just to be easier on us. Then we can just say texture size. We can do the same thing. And if we run it, I should do look at the same thing. Yep, there we go. We have a chunk. What if I can move this chunk over? Like, because I know that, chunk positions are based on unsigned integers. Um, so can we do this? So can we, get multiple chunks rendering? So I'm going to try this. And then we'll just say chunk, chunk 2, chunk 2 is equal to new chunk, new vector 3, 0, 1, 0. Oh no, that won't work, will it? Because chunks are based on two vectors. Wonder why we have a vector 3 actually, to be honest. Let's try 16. 16 blocks over, because that's how it works, I think. And then we just do chunk2.render shader. Do we have to do anything else? I don't think we have to. No, we don't. So I think that should work. Yeah, there we go. There we go. Like it's... Hold up. Hold up. Oh no, we've only got one chunk rendering. That's only a single chunk. Okay, never mind. I did something wrong here. Um, that's wrong. Okay, no, that's right. Is there something that I'm missing? Oh, because of VAO and VBO. Oh, it's VAO and VBO. It's because of these things. Wait, what is it? Where is it? Where is it? Where is it? It's because of these things, the render pipeline. This is where it's stuffing me up. Oh, because I have to allocate each one to a slot, and then I render it out. Ah. I'm gonna have to keep track of the VO and VBO. And this is...
And delete that last no. Should also make these videos and have a good day. See you. If you have any questions, make sure to join my Discord. I'll be responding them in there. And yeah, thank you for watching. Consider supporting me on Patreon so I can continue making these videos. And have a good day. See ya.
Yes. Ah, now I'm on my own from this point. Oh no. Okay. Um, I'm also gonna leave it there as well because it's a lot to take in at the moment. I'm gonna have to change a lot of this stuff as well, modify it to my own liking, well, to how Minecraft does things exactly. At least we don't need this anymore. Um, let's see. Oh, yeah. There's gonna be a lot more once we get after this part. So I'm just gonna upload this part. Um, wait, actually, we'll just get rid of the old stuff first. We still need this, don't we? Yeah. We don't, the texture data, we don't actually need a lot of this. We just get rid of that. And then we can just do, what is it? Like that. Oh, I did that wrong. Yeah, I did that wrong. Then we have to do the same thing, which is what? Um, the front was 4 and 16. No, 4 and 1? Can't remember. 4 and 16, I think it was. Or 15. Then 4, 4, 4. Bottom can be just 215. And then the top was what? 8? Let's see if that's correct. So if we do that, then if we do, what is it? Where is it? Grass. I need grass. Oh, I got the entirely wrong block. Oh my gosh. The TNT. I'm not gonna lie, it looks nice, but also it's a bit weird. At least the dirt one is correct. At least the bottom is correct. All right. Right. We're gonna apply what I learned when I did the texture thing. So look at the atlas. All right. So this was like what? So this was 15 up to here, and I went one too far across. So this has to be 3, 3, 3, 3. And what did the other one look like? Um, yeah, this was wrong. So I went too far across. I need to go 14 and down by 1. So we want 14, I think it was. No, 12. All right, so the grass is correct. Okay, we're missing the texture, so I think we went down too far. So this is 15, 14, 13. So that's 13. I went down too far. Yep, there we go. There's the grass. Cool. Even though it's not properly aligned. But that's the text data. It's not really us. At least this is correct. So yeah, that's how that works. Right. So I guess the next part is actually making a world that actually handles each chunk, and then each chunk can individually check each neighboring chunk. And then wait, how high? Wait, height of chunks MC. 256 blocks. Is it? No, 320 since the update. So how big is 320? I think it's like 320. Oh gosh, it lagged me a bit, but okay. There it is. There we go. There's our chunk. Now, of course, we're going to do asynchronous and multi-threading loading, but of course, we can't render the entire thing right now, even though it's, yeah, it's really far up, isn't it? How far does this go? 320 blocks is huge. Right, there's the end. Yeah. Our render distance is not that far, actually. So, yeah, there we go. At the top. Man, 320 blocks is huge. Just this goes to show how much thought that Mojang put into making the game kind of efficient, but even though their render is like pretty bad anyways. Hey, look, this is my renderer, so I can't really complain, and it lagged a bit. So yeah. So we've got a single chunk. Oh well. So oh wait, I'm gonna upload this stuff. Chunking. Alright, so the next part is actually gonna be so yeah, of course it's the chunking part, which is like the world chunks and all of those things, and getting blocks in neighboring chunks and all of those things. So we can actually get that set up, and then the next thing we're going to have to do is we're going to have to change the 3D array into a 2D array. So it'll be a lot more efficient then. Is it? Right, I'm not going to the wiki fandom one. Minecraft wiki. Hold on. There we go. Found it. Okay, this is the official one. So, chunk. Okay, so how high is it? 16. The the building height are 384 blocks. That is huge. Dude. Wait, hold up. So 384. Huh? This is gonna lag me, is it? Okay. No, I loaded it in. Yeah, okay. My renderer is also working. So this is, believe it or not, this is actually one draw call to the GPU. Um, and of course the chunk is empty inside. You can't see anything. So this is actually one draw call on the GPU, which is very, very efficient. But then, of course, once we start adding multiple chunks, then it's going to lag out a lot because of how the chunk is actually working because of this. So I'm going to have to actually change this because in Minecraft data, if I can see, yeah, it doesn't really matter about chunks there. Yeah, I need to find the, what is it? What did I call it again? I believe it was, I'm gonna, there we go. So yeah, currently this is a 3D array, but this is really, really inefficient. Like, extremely inefficient. I mean, we've got 3 references to a lot of things, and this, like, triples the inefficiency, so, we're gonna have to change this later. Or when I do. And then, of course, how how the Minecraft chunk data. Oh wait, no, actually. Ooh, okay. Yeah, okay, so that's the chunk thingy, but Minecraft data structure. If I can find that. Structure data. There is a data structure somewhere. Okay, well, I can't really remember it, but basically what happens is, well, let me put up Visual Studio Code. Right, so we'll just say, so basically in the Minecraft, a chunk data, it has like a block palette. And then it would have like an array of each type of block. And then like, and in each block it would have like a type of, say, the identifier, so identifier here. And then it would have all of its states. So this would have its state 1, and then it would have like a 0 or 5. It could be a true or false, whatever it could be. And then in the actual chunk data, it would actually be hello Hyacinth. So in the actual chunk data, it would have, so say for example, if you had multiple blocks, if we had, for example, a torch and then rotation, say 1, and then if you had like a grass block here, and then that would pretty much be it. So you would have no states, and then basically your chunk data would be basically your chunk data would be 0, 0, 0, or like if a block at a certain XY position is how do I explain it? So if we wanted if the chunk was actually, part of it was grass, so this would be a 0 here, and then with this 0, that would be pointing to this here. So that's how that works. And then of course you would have multiple of these zeros or something. Pretty much all of the chunk culling, if I can. Like I've already got the basics down of the chunk culling. I mean, you can't really make a voxel game without all of the chunk culling that Minecraft does, so there's not really much you can do. So as you can see here, so this is at XYZ 0, then this would be XYZ 1. So how do I explain it? So if we have like, so as you can see here, we have 0 at position 0 in the list. So the lists actually go from 0 to whatever, and then each block, well, each list would be around about the size of the chunk, which is how many chunks? About 98,000 in length. So you would have 98,000 of these numbers, specifying each and every single block at each position, and then these would be pointing to the block palette with each state. So for example, if you had 2 torches at a different rotation, you would have the same thing, but you would have 2 different states, if you get what I mean. And then of course, it doesn't actually load every single state. So if we had 0, that would be X, so X 0, then Y 0, Z 0. And then of course, the actual thing would count up like this. and then depending on how big the actual chunk is, it would have to be like 3, 4, 5, 6, 7. Let's just keep on going until we get up to 16, was it? 7, 8, 9, 10, 11, 12, 13, 14, and 15, and then you would have 0, 0, 1, like so, if you can see that. Yeah, so this is how chunks actually work. The same with structure blocks. You can actually see this same structure data. So that's how that works. And of course, this is all done in here, all done in this format. So I'm going to have to implement this format when I actually record stuff. So if we look at, well, I mean, when we're checking packets from Minecraft, it actually sends it in that same exact format. So we're going to have to do that as well. And of course, it gets a bit complicated, but that's the simplest as I can say about how the chunk actually works, or how each and every single chunk works. And of course, you would have all the block registries on the client side, so which is basically what I'm going to try and do. And I'm going to have to support add-ons as well, but I only have to support the resource pack side. So luckily, it's not. I'm only doing half the work here on recreating Minecraft, on recreating the Minecraft engine. So yeah, hopefully all goes well. Anyway, so that's pretty much how that works. Oh gosh. But anyways, I hope you all enjoyed that. I'm actually gonna finish this stream, and I will see you all next time when I start sort of learning how to do stuff in OpenGL, because yeah, I am literally using a library that pretty much I have full control over. So yeah. Anyways, see you all